As we kind of start this and we think about all of these objectives, okay, they're telling us in Despicable Me that a vector, okay, has direction and magnitude. And that's what's really important, that it has those two things. So we're going to start there. So this first lesson is really going to talk to us about the nuts and bolts of what vectors are. You might be like, why in the world do we need to know anything about vectors? Well, vectors are used in Calc 2. So if you plan on pursuing any type of STEM field and it requires more than just Calc 1, you're going to see vectors in Calc 2. If you're in AP Physics, you've seen vectors. Maybe they haven't been specifically called a vector, but that's what they are. And so we want to recognize that two vectors are equal if and only if they have the same direction and magnitude. So I'm going to show you some of those on the whiteboard here, what vectors are looking like. So we have vectors that we would say are in standard position. Standard position vectors start at 0, 0, and then they go to some point in the coordinate plane. Vector, typically call them AB. That's the point they're going to. And so I have it shown here that it's represented in two ways. The first way, it's not how you're going to represent it because you don't have the ability, even if you were to write over and over, to make things bolded. But in textbooks on Pearson and different places, you will see the vectors being bolded. So V would be a vector V, I and J, those are all vectors. And we'll talk about I and J in the second lesson a little bit more. This is how you're going to write it though. This second one, you're going to put these little vector symbols above your vector. So vector V would have the little symbol. It doesn't have to be that far above it. It just looks something like this. Okay. Vector I, vector J. So those would be our vectors. So that's how you're going to need to write them. As we look at vectors, again, they have direction and magnitude. We want to recognize that A is going to be the horizontal component. B is going to be the vertical component. So horizontal, we know, goes which way? Left and right, good. Vertical goes up and down, good. And so we're going to look at those. So remember, it's going to start at the origin. If it's a position vector, it's going to start at 0, 0, and it's going to go to a point called AB. And so we have it represented there. And then we have what's called the magnitude. We know it has direction. We know it has magnitude. So to find the magnitude, we have those double bars. They're not absolute values. They're kind of like a double absolute value. Has nothing to do with an absolute value, though. This stands for magnitude. Magnitude is a fancy way of saying length. What's the length of the vector? And so the square root of a squared plus b squared is how we would find magnitude. So we're going to talk in a moment about where that comes from.
For the magnitude of the vector, why do we need the square inside?
We're going to talk about it.
Or why do we need the squares inside of this?
Okay, let me talk. Yep, good question. I will answer that. Okay, I'm going to give you a couple things here on the whiteboard. So on this first one, what I have on the whiteboard is I have a vector. It is not a position vector because the vector does not start at 0, 0. Okay, but if we look at this vector, can we figure out how much it's going horizontally and how much it's going vertically? If I start at 2 and I go to 5, if I'm going from 2, 3 to 5, 5, yeah, isn't it true that I would have to go over 3? So my A component would be 3, and then how much do I have to go up? 2, right? Would we agree with that? So this vector could be called 3i, because we went right 3, and we went up 2, so plus 2j. We okay with that idea? Now, if I make it a position vector, I'm putting it back at the origin. So if I put it back at the origin, it would just be going right 3 and up 2. So my position vector from the origin would look something like this. It would just start at 0, 0. It would end at 2, 3. How about 3, 2? 3, 2. Okay with that idea there?
Yes.
Now, we said vectors have direction and magnitude. So if I were to put my arrow on the left side of this, would it be the same vector? No. If I put my arrow at 0, 0 and my end is at 3, 2, it goes a different direction, doesn't it? That would actually be the vector that goes back this way. Are you following me? Because if I'm starting here and going here, I would be going left 3 and down 2. So it would actually end at negative 3, negative 2. So these are not equal vectors. They don't have the same direction. To be equal vectors, they have to have the same direction and the same magnitude. Okay with that idea? And these again would be position vectors because they start at the origin out to a point. Yes?
What's the difference between that and like array?
Okay, good. Array, great question. Array, it's what it looks like, right? It looks like array. Array doesn't have to have direction. And it doesn't have magnitude because an array goes forever. I guess it does have some sort of direction, I guess, in a way. But it doesn't have a magnitude because array goes on forever with the arrowhead. When it's a vector, it actually stops. It just is telling us that it's starting here, and it's the arrowhead is telling me the direction it's going. Do you follow me there? Okay. Now, the last thing is the magnitude. And the question was, why are we squaring it underneath? Well, you could look at it here, you could look at it here. I'm going to look at the position vector. If I were to bring this down, and we said it went right 3 and up 2, what is that making? What kind of triangle? A right triangle. If this is a right triangle and we want to find the magnitude of it, isn't the magnitude just the length of the hypotenuse? Isn't it a squared plus b squared equals c squared? The nice thing is they do use a and b. But yeah, I would take 3 squared plus 2 squared, so 9 plus 4, 13, and take the square root of it. So the magnitude of this vector would be the square root of 13. Do you follow me there? It's got to be positive, can't have a negative vector. So this vector is going right and up, and it has a magnitude of the square root of 13. The other vector that I drew is going left and down, and it still has a magnitude of the square root of 13, but it's not the same vector because it's not going in the same direction. You okay with that idea? So just know that those double bars are talking about magnitude, but it's coming from the Pythagorean theorem. So again, A represents horizontal, B represents vertical, X and Y. Okay with that? Okay, so what's happening here, you can write all of this down or you can just write some of it down, write what you feel like you need. But they're going to talk about how do we write a position vector. So vector V with an initial point, they're calling it P sub 1. P sub 1, they're saying is x1, y1. So it's saying that we start at this point. That's our initial point, the starting point. And it has a terminal point, which we're going to call P sub 2, which is x2, y2. So it starts somewhere and it ends somewhere. Starts at point 1, ends at point 2. Remember, it matters where it starts and where it ends because direction matters in a vector. Well, if we want to talk about the position vector, remember position vectors start at 0, 0. Okay, what we're going to do is we're going to subtract the x components and we're going to subtract the y components. That's going to give us the a value and the b value. But notice the order that we subtract them in. We subtract x2 minus x1 and y2 minus y1. So we're taking the terminal point and we're subtracting the initial point for that either x or y value. Okay, so the order does matter. If you go out of order, your vector is going to be going the wrong direction. Okay, and we can check that. You can draw these really easily. Should not be super hard to draw vectors. So we want to make sure that we are drawing them and seeing what's happening if we're especially if we're unsure. Okay. Again, these are bolded. When you're going to see them in Pearson, you're going to be writing these little vector symbols on it. The nice thing about Pearson is they're going to have those. You're just going to be putting in A and B. But when you're writing it on a quiz next week, on the final, any of that, if you had to write it out, you would want to make sure you're using those little symbols. And again, this is distinguishing kind of the question earlier with ray. A ray would have both of the tails on the end. Okay, that would be our symbol for ray. This is showing that it is a vector. Anybody still need that? It's writing. We're in a good place. Okay, so what we're going to do next is we're going to talk about how do we write a position vector. Okay, so before that, I forgot we're gonna sketch it. So go ahead, example 1. I don't know that you need the directions. Maybe write the word sketch, but it wants to sketch the vector as a position vector again. Where does a position vector start? 0, 0, and find its magnitude. So you're going to make an xy coordinate plane. We want to have vector v equals 5 vector I minus 2 vector j. So what's my horizontal component here? 5, and my vertical component is -2. So we're going to start at 0, 0. We are literally just going to go 5 units to the right, 2 units down. That's where my arrowhead goes. And then I just draw my vector there. So it's ending at the point 5, -2. That's where the end is, but that's where your arrowhead goes. If you don't have the arrow, you have a line segment. It does not have direction. So again, that arrow is showing the direction that we're going. Okay, so it wants us to sketch it. We want to be able to sketch. Then it wants us to find magnitude. Remember, magnitude are the double bars. If you're ever unsure about how to find magnitude, a sketch is nice, because remember, we could draw in the right triangle like I just did on the board. So if we needed to, we could just kind of draw that in if it helps us. Makes a right triangle. Isn't it true this side is 5 and this side is -2? Right? Yeah. So we're going to take the square root of a squared plus b squared, we said. Again, we're just doing the Pythagorean theorem. So 25 plus 4, 29. So we're going to say it's the square root of 29. We're going to try to simplify that if we can. Can you simplify the square root of 29 any? Nope. So the magnitude of our vector would just be the square root of 29. So if it helps you to draw in the right triangle, you can do that. I'm going to take it off just because I want us just to see what the vector would look like. Questions on that? The square root of 29, you should know, is a little bit more than 5. 5 point something give us the square root of 29. But that's what we would have there. Okay, the next thing. Go ahead and write these 2 points. If you want to write the directions, you can. But basically, it's saying just write this vector in terms of I and j. Just goes back to what you wrote down just a moment ago. If your initial point is P1, -8, 6. So if you want to just not have to write as much, you could say this is your initial point. This is your terminal point. That's basically what the directions are saying. You'll see that in Pearson. But let vector v be the vector from the initial point, P1, to terminal point, P2. Write v in terms of I and j. So really, we just have to know, how do we do it? Yeah. So you want to be careful. You want to make sure, yeah, you're taking P2 minus P1. So the horizontals are going to be subtracting the x's. So -2 minus -8. That's going to go with vector I. Plus, what would I do for vector j? 3 minus 6. So that's vector j. So then I'm just subtracting the y's. So -2 minus -8 would be -2 plus 8. -2 plus 8 is 6. So 6i, and then what's 3 minus 6? Minus 3j. So this is what we think this vector would look like as a position vector. So starting at the origin. Okay. To verify this, I am going to draw a picture of what it's talking about. So if you want to draw a picture, great. Otherwise, you can just kind of watch what's going on. I'm just going to sketch it really. If P1 is -8, 6, let's say that this is P1. And P2 is -2, 3, so somewhere here. So if this is P2, would you agree that my vector is going right and down? Is that what's happening when I have 6i minus 3j? Would you agree it's going to the right and going down? So my position vector would start at the origin and go right 6 and down 3. So my position vector would just be somewhere here. So this would be vector v. As a position vector, this is just vector v, not as a position vector. Follow me there? That's just the difference. They're equal because they're going the same direction. They have the same magnitude. Questions there? If I would have subtracted in the other order, isn't it true if I would have done -8 minus -2, I would have had a positive or a -6? And then 6 minus 3 would have been +3. So I would have had -6 plus 3. Recognize that -6 plus 3 is going back the opposite way. So it's going a different direction. Okay, so that's why it would not be equivalent. Questions on that? Okay. So the last thing we're going to do in this section is we're going to talk a little bit about the objective that says we need to be able to add, subtract, multiply vectors by a scalar. Add and subtract vectors or multiply by a scalar. So that's what's happening here. So we'll start with these first two. So we're given vector v. Vector v is 5 vector I plus 4 vector j. And then we're given another vector, which is 6i minus 9j. And the first thing it's wanting us to do, it's wanting us to just subtract v minus w. Now in the physics world, typically you guys start doing this, and I don't know if you guys do it anymore, but they used to do it in physics where they would graph these, and they would add and subtract tip to tail. Does that sound familiar to anybody in AP Physics? Okay, so it's what we used to do in physics. Could be changing or whatever with the changing of the guards over the years. But I think it's important that we recognize what's happening here. So I'm going to again sketch that here on the whiteboard. So if we have vector v is 5 plus 4j. This is going to play a part in section 3 or day 3 when we do this. So we would go right 5 and up 4. So I'm just going to kind of sketch this. I'm not going to make it perfect, but that would be vector v. And it says we're going to subtract vector w. Well, vector w is 6 minus 9. So it would be right 6 and down 9. So this would be vector w. Okay. If we were adding these two vectors, we would literally just add tip to tail. So we would take vector v. It would end up at this point 5, 4 up here at the top. And I would take vector w, and I would just add the initial point at where the terminal point of v was. And I would just go this direction, and it would look something, not quite that long, but something like, oh, I guess it would be a little longer, like this. Do you follow me there? So I'm just adding this vector here, but try to make it the same length. I don't know that I did a great job, but it's going to look something like this. And then my final answer that I'm looking for would be from the position vector from the origin to the tail of that, right? That's what I would be doing if I'm adding. But this says we're subtracting. So any thoughts on what subtracting does to my vector? Makes it, yeah, it just makes it go in the other direction. You're exactly right. Because isn't it like -1, and when you multiply by -1, it changes them? So instead of going to the right and down, we are going to go to the left and up. So we would take that vector, and it would now be going up in this direction. Follow me there? So this would be vector w. So this would be v minus w. And then our final answer that we're looking for would be, if I could find a color that's different, would be the position vector starting at the origin and going to that, where that ends. So we could call this the resultant vector, so I'll just call it vector r. Follow me there? That's graphically what's happening. Now, algebraically, it's pretty simple. You literally just replace these. So we have 5i plus 4j minus, and then the quantity 6i minus 9j. Remember, we've talked throughout the year, if we have more than one term with subtraction, we definitely want to have parentheses. So we're going to distribute the negative through that. And then we're just combining like terms. So if it takes you 2 steps to do it, great. If it only takes you 1 step, that's great too. So hopefully it makes sense that we would be combining the i's together. So that would give us -1i or -i. You could do either way. And then we would combine the j's together. So 4 plus 9 would be 13j. Now, if you look at my picture that I drew up here on the whiteboard, does it look like my resultant could be just from a quick sketch, -1, 13, left 1 up 13? That's what we're getting to. Make sense there? So the visual of what's happening, so if you're talking about forces going in different directions, gravity going down, okay? And tomorrow when we talk about day 3, we'll talk about planes flying or different things flying and having wind speeds. So there's different places where you're going to see vectors. Okay, if I'm in a boat, you could use vectors. If I'm in a plane, okay, if I'm talking about forces and gravity, all that could happen. So if you look at part B, if we take off the negative aspect for a moment, we know negatives are going to flip it the other way. We'll come back to the negative. But what do you think the 3 does? If it's 3v. So what does that look like graphically?
Stretches it 3 times.
Yeah, it's basically a stretch, right? It's greater than 1. So doesn't it just mean I have 3 of these? So that's what 3v is. 3v is 3 of these vectors just tip to tail. Yeah, so we're just multiplying it by 3. It's 3 times as long. Does that make sense? If it's negative 3, doesn't that mean I'm making it 3 times as long and flipping it the other way? That's all we're doing. So we're just going to do the math. Negative 3 times 5i plus 4j plus 2 times vector w, 6i minus 9j. So take a moment to do that math. See what we come up with. If you haven't noticed, I'm not dotting my i's or my j's. I'm just putting the vector there. You're welcome to dot them if you want. What did I do? Did I do something wrong? Negative 12 minus 18. Okay, so work through that. Let's make sure we're getting negative 3 vector I minus 30 vector j. So don't forget those vector symbols on top. If you don't show the vector symbols, you will lose some points. It's kind of like not using a degree symbol when we're talking about angles. Okay, these aren't just variables. These are representing direction and magnitude, okay, for the vector. So look at letter C. If we look at letter C, it wants 7v minus the quantity of negative 3v plus 2w. Well, does negative 3v plus 2w, have we done that already? So can't we just take this and put it in there? Right, we know the resultant of that. So we're doing 7 times v, which is 7 times 5i plus 4j. And then we're just subtracting the answer we just got on part B. If you want to do all the work again, go for it, but we're just doing the same thing we did a moment ago. So go ahead and do that math. Let's see what happens when you do that. Just again, looking at some algebra, making sure we're doing correct algebra. We know that's easy to make silly mistakes, so just wanting to practice that so we don't make those mistakes, hopefully. Actually, yeah, those aren't gonna show it up. Okay, looks like we're getting the same thing. 38i plus 58j is what we're looking at there. And then the last one has these crazy bars. What do these bars mean again? The magnitude, right? So for the first one, it wants the magnitude of 2 times v. What do we get if we multiply v times 2? Yep. So what would be 2 times v? What if we just did this part first? What would I get if I took 2 times v? There you go. 2 times 5i plus 4j. So we get 10i plus 8j. Can we agree with that? So we'd have the magnitude of that vector plus the magnitude of v minus w. Well, wasn't v minus w part A? Didn't we just do that a moment ago? So negative I plus 13j. And then, don't forget, it says we're going to square them. I left that off to start with, but we're going to square each of those magnitudes. So again, don't make this hard. Magnitude is a fancy way of saying length. How do you find the length? Yeah, it's the hypotenuse. So what mathematically would we do? So we'd square 10, we'd square 8, and what do we do with that answer? Put it under the square root. A squared plus b squared equals c squared. We're basically finding c. And then we have to take that and square it. What happens when you square a square root? Yeah, it cancels out, doesn't it? So isn't this 100 plus 64? You can use a calculator to do that math, and then we're squaring it. So isn't it just going to give me 164? Because the square is going to undo the square root. Okay with that idea? Okay, try it for the next one. Try it for negative I plus 13j. Make sure you can square negative numbers correctly. That sometimes causes issues, especially if we're using our calculator. When you square a negative number, it should become positive. So we should be getting the square root of 170 squared. Again, you can use a calculator, and then I'm adding those two numbers together. So if I did my math right in my head, I should be getting 334. Seem right? So all they're having you do, guys, is square the square root. It doesn't undo the squareds inside, doesn't do anything with that. Okay, you're simplifying the stuff inside. Square of a square root was going to cancel. So 334.